Okay, so good afternoon everyone. So we are all learning this microprocessor and microcontroller, which is a program core course. So the last part of unit 5 is going to be some real-time applications of microprocessor and microcontroller. So here we are going to discuss some real-time applications which are being used in day-to-day life. So today we will have a short glimpse about a temperature control system. Next slide. So basically we are daily going through this temperature control systems. The best example is our refrigerator in our home. So what is the role of a refrigerator? So it has to maintain certain temperature which is set by us. And also we have our air conditioner. So we are using in house, our laboratories and all. So we set some temperature like 19 degrees or 20 degrees. So this system continuously works to maintain that temperature. Yes, so this is all understood. But inside this temperature control system, there are different blocks which we are all supposed to learn. And before that, apart from this refrigerator and air conditioner which we are seeing daily, there are other real-time applications. One example is server room. So you all know server room is going to produce a lot of heat energy. So definitely temperature has to be maintained. And the next one is poultry control sheds. So you all know what is poultry. So poultry is a place where all chickens are going to be kept. So they can't survive if the temperature is very high. So definitely we need to maintain some good amount of temperature. And then the central air conditioning systems. So in a big theaters, in party halls and all, we have centralized air conditioning systems. And then storage houses. So when certain grains or food materials are being stored in very large quantity, so definitely they should not be contaminated. So we should also maintain temperature in some cases. And another common example is home automation system. So our air conditioner in our house. And then food factories, because all the food items have certain temperature limit in which they get contaminated. So certain food items get contaminated when the temperature is above, and there are certain food items which has to be always maintained in low temperature, like milk, curd and all. And also many process industries, hospitals also require this. So this is a generalized application. So we are going to discuss a very simple block diagram of a temperature control system. Next slide. Next slide. Okay, so you might look like there will be a lot of circuit components, so I'll just make it very simple. So this is a simulation which was done using a simulation software called as Proteus. Okay, so Proteus is a software where we can simulate all microcontroller and microprocessor based applications. So we will have, for example, you see this is a microcontroller. Okay, so microcontroller is what? It is the brain which is going to help in controlling the process. So this system, I'll just explain what are the various components available. So for example, you imagine an AC. So what we are going to do, we are going to set temperature once AC is turned on, right? So how do we set the temperature? We have a remote. So we have buttons where we can change. Likewise, here we have a keypad, so where we can give the input. Okay, so this is one of the input device which will be connected to a microcontroller. Similarly, in AC we have a small display. We might also see the temperature in the AC. Also in the remote we have a display, yes. So to visualize the temperature, we also have an LCD screen. So we have already learnt in unit 4 about the various interfaces. So we also have a keyboard and display interface. So apart from this, you need one important element called as sensor. So I have to first know the environmental temperature, right? Only if I know, I can make the program for the microcontroller to maintain the temperature. So how can we measure this outside temperature? Yeah, we need a temperature sensor. So basically a sensor is a device which can convert any form of energy into electrical energy. So here we are going to measure temperature, so we are going to use some temperature sensor. So this sensor will measure this real-time signal which is outside, and it is going to pass the data to the microcontroller. So in our microcontroller, for example, I want to maintain only 20 degrees of Celsius. So sensor will measure the outside temperature. For example, right now in the summer, our temperature will be around 30 or 32 degrees. So that data will be fed to the microcontroller. So inside the microcontroller, we will be doing the programming. Okay, so we will be creating a logic, simple logic. I'm going to create a comparative statement. If the temperature of the environment is less than 25 degrees, okay, if it is less than 20 degrees, so our actual aim is only 20 degrees. So if it is less than 20 degrees, we do not require any cooling. Okay, so for example, the actual temperature is around 30 degree, okay, but I want only 20 degree. So the actual temperature is how much? 30 degree, I want only 20. It is high or low? It is high. So what we have to do? We have to cool down the temperature. So what we will do is we will have some control mechanism where this microcontroller will go and drive a cooler. Cooler may be a fan. So what the cooler will do, it will blow cold air. So automatically the room temperature will come down. And this microcontroller continuously keeps checking this temperature, whether it has reached 20 or not. So once it has reached 20, it will again work to maintain the temperature exactly 20 degrees. So this is the basic working principle of a air conditioner. So now other case. So we want 20 degrees, but our temperature, room temperature is 15 degrees. Suppose you imagine we are in a cold region. I want only 20, but the actual temperature is 15 degrees. So now you tell me what we have to do. We have to increase the temperature. So now what the microcontroller will do? The microcontroller will turn on the heater. It will not turn on this cooler. It has to turn on the heater. So heater will heat this air in this room. Okay, so this logic and all we have to program through microcontroller. So we have learned the programming of microcontroller in unit 3. So through that logic we will be writing the code here using appropriate tools, and then we will be interfacing these devices here. So this is one simple application. So likewise we have a lot of applications. So now this is the topic which I have discussed. So now we are going to have one small activity called active learning method. Okay, so what is this active learning method is, instead of a faculty giving a continuous lecture, we'll also involve students in this class. So after lecture is given, we'll be having a small activity. So now what I'm going to do is I'm just going to conduct an open quiz, just very basic questions, what I have explained here. Okay, so question will be projected. So whoever knows the answer, you can voluntarily stand up and you can give the answer.